Okay, the video that you are going to watch has all your trigonometric functions on it, all your right triangle ratios. It gives you more examples. We are going to talk more about trigonometry today, our trig ratios and our right triangles, and the new objective, the law of sines. So right here, we have trig ratios in a right triangle. Trig ratios in a right triangle. Well, sine of the angle is going to be the opposite side over the hypotenuse. Cosine of the angle is the adjacent side, the side that helps make it over the hypotenuse. And tangent of the angle is opposite side over adjacent or sine over cosine. These are all something that we've done before. Okay, a quick recap. Remember, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. SOHCAHTOA. If you need to make your own acronym or you want to remember a different one, then feel free to do that. Now, they're wanting, these are all right triangles. This is a right triangle ratios. These are right triangle ratios. So they're wanting cosine of x. Here's x right here. Cosine is adjacent over hypotenuse. Okay, well the hypotenuse is opposite my right angle. Okay, the adjacent side is what helps make the angle that's not the hypotenuse. So I end up with 40 over 50, always reduced to simplest terms, so 4/5. So cosine of the angle x has the ratio of 4 to 5. Tangent of angle x is here. Tangent is opposite over adjacent. Okay, so tangent is right here. Opposite is 24 over adjacent, which helps make it, it's not the hypotenuse, is 32. Always reduce. These reduce by 8. 8 goes into 24 3 times. 8 goes into 32 4 times. So tangent of angle x is 3/4. Okay? Now we go on to sine. Sine of x. Sine is opposite over hypotenuse. Here's x. Opposite is 24. So sine of x is 24 over the hypotenuse, opposite the right angle, 40. Again, we need to reduce. 8 goes into 24 3 times. 8 goes into 45 times. So sine of angle x is 3/5. So these are our quick recap. SOHCAHTOA. We have to remember these ratios. This one as well. Now this is something I'm going to have to jump in between screens. We're going to find cosine of 22, and then we're going to find sine of 73. Now, before we, before we do that, first thing I need to tell you, first thing you're going to do is check the mode in your calculator. Some of you did not do that last time. What's the mode supposed to be in? The mode is supposed to be in degrees. That's the very first thing that you're going to do is you're going to check the mode in your calculator. Then from there, we can literally type in cosine of 22, and then we can type in sine of 73. So I'm going to, I don't know if this is going to let me do it. It did. I'm going to go over to my calculator, and I want cosine of 22. I close that. Oh, what did I not do? I did not check my mode. I do know my mode is set right, but I'm still going to do that. My mode up here, let's see, is this button right here next to my function. Mode, math, print, classic, normal, scientific, engineering, float, radians, degrees. I am in the right mode. So now I can hit cosine of 22 and I hit enter. Now it is 0.92718. I'm going to write that down. 0.92718. And I'm going to go ahead and 8.3 and I'll write this down and we'll round in just a minute. Our next one was sine of 73. Okay, so I'm going to hit here. I've already checked my mode. I want sine of 73. I'm going to hit enter. And my sine is 0.956304. Okay, I will get that in just a minute. Okay, so round to the nearest 10 thousandths. Okay, this is tens, hundreds, thousandths, 10 thousandths, fourth. So we want to round to our fourth decimal place. So we'll look at our fifth decimal. That's what we're going to do. So I'm going to write it in blue, and then I'll round. So cosine of 22 is 0.92718.3. I want 4 decimal places. So I'm going to look at this 8. This 8 makes that 1 round up. So we're at, let's put it in green, 0.9272. So cosine of 22 degrees is 0.9272. Whereas sine of 73 degrees is 0.956304. Again, I want to round to the fourth decimal place. This is what I want to round to, so I look at the 0. It doesn't change it. So it's 0.9563. And I have finished, I have done those. I found the value of each trig ratio to the nearest 10,000. Next one, we're going to find the missing side. We're going to round. So all of these are going to be approximations. They are not going to be equals. They're going to be approximations. So I need to look at what they've given me and what they're wanting me to find. They've given me this angle. If I'm looking at this angle, I have the opposite side, and they want the hypotenuse. What goes with opposite and hypotenuse? Okay, well, if we remember, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. So tangent is opposite over adjacent. So opposite and hypotenuse, so we're doing sine. So sine of 43 degrees is my opposite side, which is 11, over hypotenuse, which is x. I need to isolate the x. X is on the bottom. I cannot leave it that way. So I'm going to multiply the top by x. What I do to one side, I do to the other side. Okay, and this is actually x over 1. That's why these cancel. That's in the entire purpose. On the left, I'm left with x, sine of 43 equals 11. X is not by itself, so I'm going to have to divide both sides by sine of 43, because sine of 43 is multiplied to x. So x actually equals 11 divided by sine of 43. That's where we're going to get our calculators, and we're going to put that into our calculators. X equals 11 divided by sine of 43. Now we already know that our calculator is in mode degree. So I'm going to hit 11, maybe. There we go. Let's delete that. I'm going to hit 11, and it's divided by sine of 43. I'm going to hit enter. Okay, I don't remember what my directions were, but I'm going to round 16.12907. So I'm going to go back right here to the nearest 10th. So I'm going to do 1 decimal place. So I've got 16.12972. It doesn't change the 1. So my answer, x is approximately 16.1 units. So x is approximately 16.1 units. Now let's look over here at this next one. They gave me 37 degrees. I'm wanting the opposite side. This is opposite. And then this side right here is adjacent. I don't have the hypotenuse at all. The only one that doesn't have a hypotenuse in it is tangent. So, tangent of 37 degrees is my opposite side over the adjacent side. Well, here, x is on top. It's in the numerator. So x is divided by 12. So how do you undo division? You multiply. I'm going to multiply both sides by 12. What I do to one side, I do to the other side. So I actually have 12 times tangent of 37 equals the length that I need. Again, I'm going to come over here. I'm going to pull up my calculator. And I already forgot, 12 times tangent of 37. Okay, so this is what we're going to plug in. This right here is what we're going to plug into our calculator. So let's get that back up. 12. I have to hit it right. Delete this. Delete that. 12 times tangent of 37, and I have the wrong number. 37. Hit enter. And I'm supposed to round to the nearest tenth, but I'm going to write down, it's going to 9.0426. Come back over here. I have 9.0426. This 4 leaves that 0, doesn't do anything with it. So my answer, x is approximately 9.0 because they said to the round to the nearest 10, so I'm showing that I do have 1 decimal place. Okay? Now it is very important that you do show your work when you're doing this algebraically to make sure that we have the objective down and to show that we know what we're doing. It's easy to put it in our calculators wrong or anything else, and that's an easy enough fix. Okay? Now, we're going to get a new type of question. Now, if you'll notice, we're looking for an angle this time. We still have right triangles, so we're still going to use our right triangle ratios. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. So we're looking for this angle. You can name it A, you can name it X, I don't care. Okay? I'm going to name it angle F, F for fields. Okay? So F, I have this side which is opposite. I've got this side which is adjacent. What goes with opposite and adjacent? Tangent. So tangent of my unknown angle, I called it F, is opposite side 13 over adjacent. Oh, wow, man, this is new. Well, here's the thing. When we know what the ratio is, okay, what we're going to do is we're going to find the inverse of our ratio to get our angle. Okay, I heard what you said. Inverse of the ratio to get the angle. Well, this is what it looks like on paper. Tangent inverse is to the -1 power of my ratio, which is 13 over 11, equals my angle. That's simple enough. I'm going to leave it like that for just a little bit. We're going to come back to it because we're going to put those into our calculators in a minute. Okay? Let's look at this next one. This one, I'm going to call it F again. Why? For fields. Okay? We have this opposite side. Okay? And we have this side which is adjacent. Oh, we're going to use tangent again. All right, that's all right. So tangent of my angle is opposite over adjacent. You can reduce if you want to. Do you have to? Not for this part. So again, I want my tangent inverse of my ratio equals my angle. Okay, I can do that. I can plug those in my calculator. Hardest part is to know how to write them. Okay, let's see if I've got this one. Looks like these are all, maybe, no. This one right here, okay? I want, it's F. Oh, but look there. This one, I have the hypotenuse, because it's opposite my right angle, and I have the adjacent side. What goes with adjacent hypotenuse? Cosine does. So this one, cosine of my angle, is the adjacent side over my hypotenuse. And again, I want the angle. So cosine inverse of my ratio equals my angle. Okay, I'm going to have to write all these down in a minute because we're going to put them all in the calculator. This one right here is our last example that we're going to do. This is what we're wanting. I'm going to call it F. F for fields. I don't care what you call it. This is the opposite side. But this side right here is my hypotenuse. My hypotenuse because it's opposite my right angle. So what goes with opposite and hypotenuse? Sine does. So sine of my angle is my opposite side over my hypotenuse. So my angle is sine inverse of the ratio of 37 over 40. So I'm going to write all these down right quick. Number 3 is tangent inverse of 13 over 11. Number 4 is tangent inverse of 16 over 18. Number 5 is cosine inverse of 35 over 48. And last but not least, number 6 is sine inverse of 37 over 40. Okay? Now, we're going to plug all of these into our calculators. I want to emphasize, if it is not on your paper, if that is not on your paper, I don't want you picking up your calculator and putting it in there. I want to see it. If it's not on the paper, it doesn't go in the calculator. That way I can see if there's a disconnect in between what we have on our paper and what we put into the calculator. So we're going to pull up the calculator. Again, we've already checked. We know it's in our mode. Now, but this is just tangent and sine. We need sine inverse, tangent inverse, cosine inverse. If you look very carefully in the little blue on my calculator, and I believe on your calculator it's in white. No, it's in green. Okay, I'm not sure if you can see it very well. I think it's a little dark. Okay, but you have sine, cosine, and tangent, and right above it is you'd have to hit your little second function. Second, and you have your sine to the negative 1 power. So you will have those on your calculator as well. Okay, so I have to hit my second or my shift key. So I hit my second function. Oops, I need to do that. I'm going to hit my second function. No, I need to get rid of this. Okay, second function, and you see how I have a little arrow? It says, okay, I'm going to use my second function. I need tangent inverse. So I find my tangent button, I hit tangent inverse. You'll see the little negative 1 come up, and then I want 13 over 11. 13 over is the same as divided by 11, and I close it, I'm going to hit enter. So I get 49.7636. 49.7636. Our next one, I'm going to do tangent inverse of 16 over 8. Tangent inverse of 16 over 8. So same keystrokes, second function, tangent, and I want 16 over 8. Okay, now if you had gone ahead and just done it over 2, you're fine there as well. I'm going to hit enter, and I get 63.434, 63.4349. Okay, our next one is cosine inverse of 35 over 48. Second, cosine, I see my little inverse there, that's really important to look for, 35 over or divided by 48, close that, hit enter. 43.1834, 43.1834. Sine inverse is our last one. Second function's sine. See the little inverse come up? I want 37 over 40. Close my parentheses, hit enter. 67.668. 6683. Okay, so now we're going to come back over here. We're going to look at our directions. Oh, this should be easy. Round to the nearest degree. So it's an approximation. We're going to round, but that's okay. Okay, this gave us 49.7636. 7 makes 49 go to 50. So my angle F is approximately 50 degrees. Okay, so if I'm just giving my answer, I'm going to hit 50 degrees right here for 3. On number 4, I've got 63.4349. That 4 makes that 3 stay the same. So it's approximately 63 degrees. So I'm going to put 63 up here. This one here, 35 over 48. That gives us 43.1834. That 1 makes that 3 stay the same. So we're going to get approximately 43 degrees. Number 6 is our last one. We have 67.6683. This 6 makes that 7 round up. So we should get 68 degrees. Okay? The hardest part about all of this is knowing that when you're looking for the angle, you have to find the inverse of the ratio. When you're looking for the angle, you have to find the inverse of the ratio. All right. Now, we're going to get law of sines. Law of sines can be used in any type of triangle. It does not have to be just a right triangle, okay? And there's a couple ways that you can set it up. You can set it up sides over angles, or you can set it up angles over sides. And notice, law of sines, you're using sine. Sine of angle M over side M will equal sine of angle B over side B, which equal sine of angle F over side F. Or you can flip it. Side M over sine of M equals side B over sine of B equals side F over sine of S. Doesn't really matter. One thing I do want to let you know, and it just kind of depends on who wrote your presentation, who wrote your test, who's actually presenting your presentation. If this is a capital F, the side opposite is a lowercase f. Since this is a capital M, the side opposite is a lowercase m. Since that's a capital B, the side opposite is a lowercase b. That's just how they are all, that's just how they are all set up, okay? And they can also do it over sides too, okay? Sine of M, the side is FB. So sine of M goes, let's go back. Sine of M goes with side FB. Sine of B goes with side FM. Sine of F goes with side MB. So it doesn't matter if you use the sides or lowercase letters. Like I said, sometimes depending on who wrote your paper, who wrote your questions, it just kind of depends. You have to be familiar with both ways that it's written. Okay? Now, if we look at this, one thing I want to tell you, you have your sine of your angle over the side. Has to equal another sine of the other angle over another side. And it doesn't really matter how you do it. You're gonna have 3 of the 4 information, okay? And of course you have your third side, or third angle over your third side. So it just kind of depends. They're specifically looking for this side right here. And since it's opposite angle B, this is actually side B. I don't care how you think of it, does not matter to me. Now, what I tend to do is if I'm looking for the side, I tend to put the side over the sign. So B goes with sine of 59. Or I could have written side AC, that side, goes with sine of B, which is 59. Does not matter. Does not matter how I did it. Okay? Now I have to find 2 other measures. Well, I've got this measure here and this 91. So I actually have side BC, which is 28. Because this is side, over sine of 91. Same here. Side of 28 goes with sine of 91. You can see it's set up exactly the same. The only difference is I put a B here and then you can put an AC there. Doesn't matter. Here's the kicker. I've got to isolate B. Alright, I can do that. What's done to B or AC? Either one. B is divided by sine of 59. How do you undo division? You multiply. So I'm going to multiply this side by sine of 59. And actually sine of 59 over 1. So I multiply this side, I don't know why I wrote 5, by sine of 59. And again it's 59 over 1. This cancels. I'm going to erase this. B is left by itself. That is exactly what I wanted. On the right side, I'm literally left, and here's how we need to think of it. This is over 1. 28 times sine of 59 divided by sine of 91. That's literally what I want. Okay? And I'm going to jump to my calculator, and I'm going to plug this information into the calculator. It says round to the nearest tenth, 1 decimal place. So I'm going to write this down so I have it. I have 28 times sine of 59 over sine of 91. Now, there's several ways that you can do this. Okay. I am going to put it into a fraction form, what it actually looks like. So I'm going to hit my math key on your calculator. Those of you that have this blue calculator right here, let's get under there. This button right here, this N over D, let's see if we can, which is found right above your sign, this N over D, you can actually hit that, and your fraction button will come up. Okay, you can see that it's numerator over denominator, so you can do that. Okay, but I want math. I'm going to go over here to my fraction. I want numerator over denominator. I'm going to hit enter, and you see it looks just like the little TI-30XS. Okay, and I have to type in 28 times sine of 59. 28, and I'm not going to hit my multiplication button because if I hit sine of 59, I'm still right. Sine, notice I do not have sine inverse, that's not what I want. Sine of 59, close that. And then I have to arrow down because I need to divide by sine of 91. Close that. Now, if you'll notice, this looks exactly like what is written on my paper. I'm going to hit enter. I get 24.004. 24.004. So I come over here, okay, and this is 24.004. It says round to the nearest tenth, 1 decimal place. So my side AC is approximately 24.0 units. 24.0 units. Oh, no, it's not units, it's actually centimeters. They gave us units, I'm sorry, centimeters. Don't forget your units. Since they gave it to us in centimeters, we give it back to them in the units that they gave us. Again, this one, not a right triangle. We're going to have to use our law of sines. That's not a right triangle, so we can't use opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. That's not an option. We're going to have to use our law of sines. They want side BC. They want this side right here, okay, this side. So I'm going to put a little a there, okay. Again, I have sides over angles. So I'm going to put my sides on top. That's just how I do it. You don't have to. So side A over angle A. Let me erase that so you can see. Angle A is sine of 91 equals, oh, well, here's where we have to be careful. They gave me this angle, but they gave me that side. How can I find that angle measure? Well, that's easy. The angles of a triangle add to be 180 degrees. So we're going to add 91 and 59. We get 150. We're going to take 150 from 180, and that's going to give us 30. So this angle right here is a 30-degree angle. So we have side over sine of 91 equals sine, which is 7, over sine of 30. We had to use our previous knowledge of knowing that the angles of a triangle added to be 180 degrees. And again, we're going to isolate A. A is divided by sine of 91, so I'm going to multiply both sides by sine of 91. And again, this is over 1. This was the whole purpose. A equals 7 times sine of 91 over sine of 30. And that's exactly what I'm going to type in to my calculator. 7 times sine of 91 divided by sine of 30. So, pull up my calculator. I'm going to put it in fraction form. Okay, enter. There it is. I have 7 times sine of 91 over sine of 30. I'm going to hit enter. 13.997. 13.997. I come back here. So this is 13.997, round to the nearest tenth. This is going to make this go up, which makes that go up. So BC is approximately 14 yards, because they gave it to us in yards. Okay. The most challenging part would be keeping our algebra straight. The most challenging part will be keeping our algebra straight. So again, I want to emphasize, if it is not on your paper, it does not go in your calculator. Okay, let's see what they've given to us here. I want an angle measure. I want the measure of angle C. Okay, so I'm looking for an angle measure. Okay, 11 goes with angle C. So sine of angle C over 11, because those go together, equals angle measure over side measure equals sine of 108 over 17. Okay, multiply both sides by 11, because I need to isolate my variable. So sine of angle C equals 11 times sine of 108 over 17. I can multiply in any order that I want to. Now, here's the kicker. If you remember, when we're looking for an angle measure, we use the inverse function. So, let me do it this way. So, sine inverse. inverse of all of this, 11 times sine of 108 over 17 equals my angle, or equals the angle measurement. So sine inverse of all of that equals my angle measure. All right, so we're going to have to write all that down. Sine inverse of 11 times sine 108 over 17. Okay, so we're going to come back over here. Sine inverse. Shift key, sine inverse, made sure I have the -1. I still want to use my fraction. I want it to look exactly like my paper looks. So I'm going to hit my fraction option. And in the TI-30XS, it's a little simpler, but there's my fraction. My numerator is 11 times sine of 108. And then I'm going to go down to, and I divide by 17. Now notice I need to close those parentheses. And I already know, because I've been working, that my calculator is in degree mode. I'm going to hit enter, and it's 37.980. 37.980. So come back over here. Okay. Round to the nearest tenth. So they didn't tell me to round to the nearest degree this time. I want to the 10th. So this is 39.980. This 8 makes that 9 go up, makes that goes up to 40. So angle C is approximately 40 degrees. And since they said to the nearest 10th, I'm going to put the point 0, 40.0 degrees. Okay? Over here, I'm finding an angle measure again. So I'm going to end up using the inverse function. Okay? I'm looking for an angle. So sine of angle C goes with the side opposite, which is 22, equals sine of 138 over 43. And then we're in centimeters, but it doesn't really matter because the centimeters end up canceling. Okay? I'm going to have to multiply both sides by 22. These cancel, that's the whole purpose. Sine of C equals 22 times sine of 138 over 43. So in my calculator, I'm typing in sine inverse of 22 times sine of 138 over 43. So let me write that down so I do not forget. 22 sine 138 over 43. So I'm going to go back to the calculator. Calculator is going to save our bacon in this particular assignment. So again, I'm looking for an angle measure. We're doing law of sines. Now, anytime I'm looking for an angle measure, I'm going to use the inverse function. If I'm looking for an angle measure in a right triangle, I could use sine inverse, cosine inverse, or tangent inverse in a right triangle. When I'm using the law of sines, when I don't have a right triangle, okay, I'm going to use sine inverse. So again, I'm going to type it in exactly like it looks on my paper. So this right here is going to be exactly what I type into my calculator. All right, so I hit second, sine inverse, look for that. I want to type in my fraction. I want to be able to use that. Okay, I want it to look exactly like it. So I have 22 times sine of 138 over 43. I'm going to close those parentheses, hit enter. I get 20.019, 20.019. Come back over here. This is going to be 20.019. That 1 doesn't do anything to the 0. So measure of angle C is approximately 20.0 degrees. Again, your algebra and having strength in your algebraic manipulation is very important. All right. Okay, we're still doing laws of signs. Okay, this time it says find each measure indicated. Find each measure indicated? Well, they didn't indicate a measure. So let me check. I don't think it's find each measure indicated. I think it is solve the triangle. Find each unknown measure. Okay, each unknown. Can't spell unknown for whatever reason. Okay, this is also known as solving the triangle. So in other words, we're going to get every measure that we don't currently have. Okay? Now these are not right triangles. They've labeled them, they're not right triangles. So the question is what do you want to find first? We're going to round angles to the nearest degree. And we're going to round sides to the nearest tenth. Okay, so angles are going to go to the nearest degree, sides are going to go to the nearest tenth. In your homework, be sure that you follow the directions and round however it specifically tells you to. Okay, so this is find each unknown or solve the triangle. It could be asked find each unknown, it could say solve the triangle. So we need to get this side. So we need, these are the sides we need side AC, we need the measure of angle C, and we need the measure of angle B. We have three things that we know, and we need those three things. So the question is what do you want to find first? I think I want to find angle C first. So if I'm looking for an angle, again, I'm not in a right triangle, so I'm going to use law of sines. Sine of angle C goes with the side opposite, which is 14. Equals will be in proportion to sine of 89 over side 32. This is just like the problems we did on the slide before. I'm going to multiply both sides by 14. So sine of angle C has to equal 14 times sine of 89 over 32. I'm looking for an angle. So I actually want sine inverse of all of this. 14 times sine of 89 over 32. That is going to give me, the measure of angle C. And I said we're going to round our angle measures to the nearest degree. So let me write down 14 sine of 89 divided by 32. We're going to put that into our calculators. Okay? So, second, sine inverse. I want my fraction. I want my fraction in there. Enter. I have 14 times sine of 89 over side 32. I'm going to hit enter. 25.94. 25.940. Come back over here. Angle C is 25.940. I said we were rounding to the nearest degree. So angle C is going to be 26 degrees. Okay, it's approximately 26 degrees. How do we find the measure of angle B? What do the angles of a triangle add up to be? 180. So I take 89 and I'm going to add 26. I hit 36. Add 26, I get 115 from 180. Well, angle B is going to be 65 degrees. So I just found Angle B, 65 degrees. So I've got two of the measures that I need. Now I just need to find side AC. I'm going to use what they have given me. Not what I found, but what they've given me. Okay? I'm going to take, I want side AC. So side AC actually goes with sine of 65. That equals, and I guess I'm going to use these two. You could use these two. You'll get the same answer. Doesn't matter. I'm going to put 32 side 32, because I want side over angles, over sine of 89. How do I get AC by itself? I'm going to multiply both sides by sine of 65. So side AC equals 32 times sine of 65 over sine of 89. I'm going to put that into my calculator. 32 sine 65 over sine of 89. Grab my calculator. Again, I want it to look like a fraction. There's my fraction. So I'm going to hit 32 sine of 65 divided by sine of 89. I'm going to hit enter, and it's 29.006. So 29.006. I said we're going to round to the nearest tenth. Okay, that's there, so it'd be 29.0, approximately 29.0. Don't forget your units, kilometers. A lot of work when we have to just solve a triangle, get all the unknowns. But if you can get one of the unknowns, you can get all of the unknowns. Doesn't really matter. We're going to do 14 is our, I believe, our last example. Okay? I'm going to go ahead and erase this and give myself a little bit of room. Okay, and again, I'm going to solve the triangle. I'm going to get all the unknowns. This one's going to take a little bit more because I have to find two of the sides. Now, finding angle A is very easy because all I have to do is add 122 and 21. I get 143. Subtract that from 180 is 37. So angle A is 37 degrees. So that's the first thing I'm going to do. Measure of angle A is 37 degrees. Okay? Now I'm going to have to find side BC. I'm going to label it little a. Well, I better not. I better put BC. Side BC. I need to find that side, and I need to find AB. Okay? Let me just do AB. The question is, which one do you want to find first? Because it doesn't really matter. I'm just going to kind of go in alphabetical order. BC was the first one that I wrote down, so that's what I'm going to find first. Okay? So I'm looking for this side. Side BC goes with the angle opposite, sine of 37. So that is going to equal. Now here's the thing. I can't use angle C because I don't have that side yet. Don't have it. Okay? So what I'm going to have to do is use the side that they gave me. They gave me 19 meters. That goes with sine of 21. To isolate BC, I have to multiply both sides by sine of 37. So BC, sine BC will equal 19 times sine of 37 over sine of 21. Because this is the same as over 1, multiply straight across the top, straight across the bottom. So I'm going to plug that into my calculator. 19 sine 37 over sine 21. So I'm going to come back over here, pull up the calculator. Again, I want mine to look like the fraction, okay? because I make less mistakes that way. I'm gonna hit 19 times sine of 37, close my parentheses, go down, over sine of 21. Close my parentheses and hit enter. 31.907. 31.907. Okay, I said we were rounding to the nearest tenth, so this is 31.907, so it's 31.9. So BC is approximately, our units are meters, 31.9 meters. 31.9 meters. Okay? So now I need to find side AB. Okay? So if I'm looking for side AB, no. Yes, AB. If I'm looking for side AB, that goes with sine 122 degrees. I don't like the way that's written. Side AB goes with sine of 122. And I'm still going to use what they gave me. I went side over angle, so I'm going to go side 19 over angle 21. Sine of 21. I need to isolate AB, so I'm going to multiply both sides by sine of 122. Okay, these cancel, that was the point. Side AB will equal 19 times sine of 122 over sine of 21. So I'm going to come back over here. Okay, now I'm going to show you something. On your, no I'm not. Okay, so I'm going to hit my math. I want my fraction. I'm going to hit enter. Okay, I have 19 times sine of, I forgot what it was, sine 122. So this is what I'm going to put in there. Okay. 122 of 122 over sine of 21. I'm going to hit enter. 44.961. 44.961. Come back over here. This is 44.961. This, if I'm rounding to the nearest 10th, I look at the 6, which makes the 9 round up, which makes the 44 go to 45. So it's going to be approximately 45 meters. So again, I solved the entire triangle.